So it's my great pleasure to introduce today's keynote speaker, Dr. and Professor Rose Yu. Dr. Yu is an associate professor in computer science and engineering at UC San Diego, where she is a leading voice in the field of artificial intelligence. She has received some of the most prestigious honors in the field, including the Presidential Early Career Award for Scientists and Engineers, the DARPA Young Faculty Award, and the NSF Career Award, and faculty recognition from Google, Meta, Amazon, Adobe, and just name a few. She has been named one of MIT Technology Review's Innovators Under 35. She's not just advancing technology, she's helping shaping the next generation of AI for scientific discovery. Please join me in welcoming Dr. Rosie.
Thank you so much, Helen, for the kind introduction. It is a great honor to be speaking at this distinguished event and have the opportunity to interact with you. So I direct the Spatial Temporal Machine Learning Lab, and then our goal is to advance AI for some of the most challenging problems at the frontiers of science and engineering. Many of you have probably seen these headlines. How many of you have ChatGPT on your phone? Oh my God. Okay. And you probably saw this news also about something called DeepSeek, the Chinese app that has got a word talking. The founder of DeepSeek actually came from the same university that I am, so I'm very proud of that. You know, a lot of you come from industry, and obviously there's a lot of AI now in industry. This is a plot about number of companies mentioning the word AI in their Q1 earnings calls. And you can see there is an exponential growth starting from the year of 2022. According to different agencies, by McKinsey, it said that AI will add $2.6 trillion annually to the economy. Maybe that has to be discounted now with the stock market. And will raise global GDP by 7% in the next 10 years, according to Goldman Sachs. It will impact 10% of the tasks carried out daily by 80% of the workers. And that 80% of workers perhaps include both you and me. So let me ask you a question. What is AI? Can I get a volunteer? I don't know you, I'm just going to ask you.
Artificial intelligence and its means by which machines can carry out processes to analyze, to decide, to do many of the things that were previously thought only possible by humans.
That's an excellent answer, thank you. And Tom, I just know you in the morning. What do you think?
I think it's an inflection point in history. I think it's going to dramatically change our world.
That's the impact of AI. That's not the definition of AI.
Artificial intelligence will replace human intelligence.
Artificial intelligence will replace human intelligence. Okay, so you're close. Let me give you my definition. Where there is not my definition is Alan Turing's definition, right? So according to Alan Turing, what we mean by AI is that we can create machines that can learn like humans. It's not we're creating machines that are as intelligent as adults, but rather we're creating machines that are as clever as a child. Because what's powerful about a child is that they can, subject to different type of education, they can become smarter, stronger, and more intelligent. So that's the art behind AI. So let me give you a very concrete example, right? We're talking about supply chains. So USPS is very important component of a supply chain. And USPS actually set up a very first example to deploy AI to improve their efficiency. So this is a picture of a worker at USPS trying to sort out mails. They need to decide how to send these mails to different locations. So first we have a machine, right? And this machine is the entire body of a machine, and it basically take an algorithm, figure out where it's going, and then put a mail in a bin. But what I haven't talked about is what is the brain of this machine. What is determining how to decide the address of these mails. So that's the area that I study, which is called machine learning. So machine learning is the brain of AI. And it's a set of algorithms and models that can learn from data. So first we have to have data, right? And in this case, we have the data all of hundreds and thousands of mail. And then on every mail, you can see there some handwritten digits specifying the target location of this mail. In this case, you can probably recognize it's 01970. So these are handwritten digits. So how can we use this data to train a machine that learns to recognize the destination of those mail? So then that comes the very classic AI algorithm. We have this data, we curate them, and then we label them. So for each of this image, it's a tiny picture of a zip code on the mail, and you can see they're hand labeled as some of them 5, some of them are 8, some of them are 1s. But they're not very standard because they're handwritten digits. Right? And humans make mistakes too because handwritten digits are messy. So we have this data curated in large amount. By large amount, I mean 1 million. 1 million examples have been curated, hand-labeled, and we're going to train a model, which is the deep learning model. This is a class I just taught 10 minutes ago, before this forum, to 300 undergrad and grad students. And we built a model which is a stack of neural networks that try to mimic human brain. So it look at this tiny image of a 3 and then pass through hundreds of neurons and trying to recognize the pattern in this image and then finally spit out an answer that is a 3. And that's the brain of this big machine that is operating in USPS. And that has significantly improved the efficiency of USPS, but not so much because we know UPS is much more efficient than USPS. But that was actually developed 20 years ago. In 20 years ago, and this is a demo from the 20 years ago, right? And this network is called LITE. And I'm going to show you a live demo of how this brain of AI is going to look at an image and then spit out an answer, which is shown here. And that's the digit that it had recognized. So that's the brief history of last course on AI. And this is a supply chain forum. And obviously, AI is the buzzword in this forum and also around the world. This is an example for AI success. So what you're seeing here is the performance of the basic utilization of AI for the high performance in the industry. So there are about several hundreds of companies. Some of them are categorized as high performers. Some of them are categorized as low performance, and they're in lighter blue. And you can see for different categorizations or different processes during the supply chain, if you use more AI, and you're more likely to become a high performer. So there's actually twice as difference between high performer and low performer when it comes to utilizing AI in demand forecasting, in order management, and supply chain planning, logistics, and operation into business planning, which shows there's a lot of potential that AI can bring to this area of supply chain. But there's also a failure case. So in 2024, now it's 2025, 2024 December, OpenAI released a software called Sora. What it can do is that you will tell Sora a sentence description and it will generate a video for you. So in this case, I'll ask the Sora to generate a video called a sport telecasting of a gymnastic performing an aerial flip during a floor routine. So I want Sora to generate a video of this kind of situations. OpenAI claims they have the state-of-the-art video generation model, and their model is trained on a huge amount of video and text data and has learned the physics of the world. But let's look at whether they actually learned the physics of the world. It's pretty horrific, right? So, by looking at this video, we may ask, well, it looks pretty terrible as a video for entertainment purposes, probably that's okay. But we're talking about problems in science and engineering. Predicting something that is not physical is going to create huge problems. There's a lot of stake, there's a lot of things at stake. So that's basically what we set out to do to address this problem. So the research in my lab trying to address these fundamental challenges in AI. In a sense, it doesn't have a framework of physical reasoning. So in modeling the data from the physical world, a lot of people will use rigid models and mathematical models to describe the phenomenon in the data, but obviously these models are very rigid. So the promise of AI is to use this very expressive set of models in distill very efficient algorithms to relax the very rigid assumptions in existing physics-based modeling so that these algorithms can really scale to large amount of data and more complex problems. But on the other hand, when we're dealing with problems in science and engineering, especially for those high-stake applications, we need to make sure that the domain knowledge in these areas from healthcare, from transportation, from supply chain, perhaps, that we want to distill these domain applications into AI models so they can become more easier to interpret and they can learn in regions where we have never seen data before. And physics is such a fundamental concept in the modeling of the world. And by using these first principled ideas, such as differential equations, mathematical models, symmetries, we can then allow the AI system to reason about underlying principles in the data and be able to generate more physically consistent predictions, and eventually towards the ultimate goal of building trustworthy AI in science and engineering. So I have written a paper about this published at the PNAS, the Proceeding of National Academy of Science, describing this framework of a hybrid system to distill physical knowledge into AI models, and then using AI models to relax the assumptions and computational burden of existing physics-based and mathematical-based modeling approaches. And then for that, as Helen mentioned, I was very fortunate to receive the MIT Technology Review 35 under 35 award last year. Now I'm no longer 35. So then the quote is that by applying the role of physics, she made AI systems more practical. So let me show you some examples of this kind of framework just in terms of applications. And I will not touch too much about how exactly we did it, but just to show you we can do it. For example, when I was studying in LA, I was so annoyed by the traffic problem. And then I thought about better ways to forecast the future traffic patterns. And this is the video showing like the sensors evolving over space and time and bubbles representing the accidents in different road segments in LA. So before, engineers in traffic management had to come up with mixed integer-based programs to figure out the traffic pattern and then plan for traffic congestion and direct the traffic and correspondingly. And these type of models are very rigid because they don't rely on the actual data. With the emergence of sensing technology, now we have very high frequency data about the real-time road situation. So we thought about using deep networks, building the very first deep networks to accurately forecast the real-world traffic. Just to give a notion of how hard this problem was, right? Before, people were only able to forecast accurately for the next 5 to 10 minutes for real-world time traffic. And with deep learning algorithms that we deployed, we were able to accurately forecast the real-time traffic patterns up to 1 hour. And then this technology was actually deployed by Google in Google Maps for forecasting the traffic patterns. So sometimes when you use Google Maps to navigate your route, you can think about our technology that plays a tiny part in this behavior. And then recently, we have been collaborating with climate scientists, right? So in climate science, you have a very similar problem. So what typically happened in climate science is that climate scientists would run this very complex partial differential equation based simulations to understand the effect of carbon emission, the effect of EV charging, and all these different policy changes on the downstream impacts, say temperature, precipitation, agriculture, right? And running this kind of simulations require us to solve partial differential equations at different resolution and to model the energy transfer from the ocean to the land to the atmosphere. So you can imagine solving this kind of equations would take a long time. In fact, to run a climate model at a global scale, you would have to wait 6 months to get the scenario. But imagine you are in a time crunch and you want to know the effect of tariffs, right, for supply chain tomorrow. You can't wait for 6 months. So what we set out to do is to build a deep learning model that can speed up this process. So we built a generative AI-based model called diffusion-based model that can emulate the process of physics-based engines. So as you can see on the left, the climate model video, which I'm going to play in a little bit, is actually coming from physics-based models. And then the middle and the right ones are the generated outcome from our emulator. So you can see like the emulated predictions are actually very close to what we have from the physics-based model, especially this very intricate turbulence patterns that are very hard to capture by existing deep learning models. And this model actually was used by L.I.T.E Institute in Seattle, where we obtained 25 times speed up at the state-of-art emulators for global climate. And this is actually for the first time we were able to emulate global climate at 6-hour resolution stably for 100 years. And then this model now is showing we are expanding this model in collaboration with Google DeepMind, hoping to build a much more larger scale emulator for global climate.
Hi, Oceanside Perspective community. Here we are today with the Oceanside Perspective founder and CEO, Helen Wang. Helen, can you tell us a little bit about OP for the viewers that are new or who may not even know what OP is about?
Yeah, so Oceanside Perspective, I would say, well, first of all, we are content creator for the purpose of education. And we are a nonprofit, so we really care about our mission and impact. What is our mission? We have a tagline called LITE Beyond Generation. So hopefully that people who are really interested to learn more about the leadership, innovation, technology, and entrepreneurship, which is a short LITE, across generations.
We also work with the CDC to solve a very similar task, because they are also bugged about the slowness of the simulation, right? During the epidemic years, they wanted to know the effect of vaccine allocation or school lockdown on the trajectories of future pandemic. So their simulation depends on the stochastic multi-agent based simulation to account for different mobility patterns. So running their simulation takes about a week. And during the wartime of COVID, so we started this project during the years of COVID, and the officials from CDC asked us whether we could do something faster than what they have for emulating potential scenarios of pandemic. So that's what we set out to do. We built this stochastic emulator that can generate not only the mean predictions of the pandemic trajectory, but also the confidence intervals in the prediction. Because in a lot of the decision critical situations, we want to assess the risks of our prediction. And this kind of confidence intervals is critical for risk assessments. And you can see that the prediction from our model in blue almost fit perfectly with the baselines coming from physics-based simulators. And then this is a little bit more technical. So we actually, instead of training the model on a large number of simulations, we have a simulator in a loop kind of training scheme where the model only selects the relevant regimes to query a simulator, and then that significantly reduced the number of training samples we require to train this model. And I want to mention that after we deployed our surrogate model, it was able to generate one scenario in 1 day rather than 1 week. So that's a lot more saving in turnaround time. We also participated in the national forecast for COVID-19. So the task there was to forecast the next 4 weeks of pandemic given the historical information. So there were 40 or so national teams in this competition, right? And then here you can see the UCSD is on the number 1, right, on this ranking for uncertainty quantification. I know L like ranking. We got number 1 for you. Okay, so and some other times, right, beyond just speeding up complex simulations, generating what-if scenarios, we also wanted to know the question of why. And that's such a fundamental question in science and engineering. We wanted to set the inquiry to understand the causes behind different phenomena. So that's a very well-known problem called causal discovery. But in causal discovery, it's a very computational inefficient problem. It's an NP-hard problem, right? So before, without deep learning, people basically rely on this kind of genetic algorithm to search in all kinds of possibilities of causes and consequences. And we have developed a deep learning-based causal discovery algorithm that is much faster and much more scalable than existing causal discovery algorithms, so they can discover interesting phenomena about, say, financial market. There is what is driving the changes in financial market crashes, or what changes the prices of different stock market. Or we can apply this at a global scale to climate data and trying to discover also known phenomena in climate changes, such as Northern Atlantic Oscillation, which is a very well-known climate phenomenon that is related to global warming. And then finally, of course, I started out with the talk of language models, right? And you can see so far we haven't worked on anything related to large language models, because to us, large language model is just an application. It works on a different data modality of text, right? But then if you think about it, the large language models only understand well about text. But in a lot of science and engineering problems, we have a lot more data modality than text, especially numbers. The time series data, the spatial temporal data, they're all numerical. And then when we think about, generative AI or language models, they're terrible with understanding numbers. So what we set out to do in the new endeavor of our lab is to overcome this problem with our hybrid framework, trying to inject physics, knowledge, simulations, numbers into language models so that our language models can understand both the text and the numbers, and then hopefully become a much more useful, comprehensive assistant for you in your work pipeline, right? So in this set of work, we basically coupled a language model with a physics-based simulator, and there's some technical intricacy of how we can distill the knowledge of a physics-based simulator into a language model. And then in terms of the actual results, we can get much more accurate predictions for this engineering or science-related questions than state-of-the-art models like GPT-4o or Cloud 3.5, if you know what I mean. Okay, and then recently we have worked on problems such as using language models to understand numerical time series. And basically what we found is language models are terrible. We're just simply detecting anomalies in time series. So that basically carved out a large unexplored space to integrate multimodal data, those that are textual, that are discrete, versus those that are numerical, that are continuous, and how can we synthesize them to generate much more useful AI algorithms. So AI is a very exciting area, as you probably have seen from my talk. And in general, it plays such a fundamental role in computing, in engineering, in business world, in almost every part of our life. So we can imagine a future where a human scientist, a human engineer, or a human businessman work with an intelligent AI engineer, AI assistant, AI decision assistant, AI research assistant, or AI analyst, and then you can go through the entire pipeline of hypothesis generation, data collection, model building, verification of hypothesis, and experimental design. So we can imagine a future where human and AI are co-piloting with each other and create a much more symbiotic world. And that requires a lot of advances at the intersection between AI, science, engineering, and business. So I hope my talk today can inspire you to think along this direction. And of course, there's a lot of things we need to do research on, and we will also welcome your input and support. Thank you so much, and this is my contact information and the funding support. Thank you. I think we have some 10 minutes for questions.
So, Rose, I want to say this in front of Al. You're extraordinary.
Oh, thank you.
Because the challenge we have in AI with LLMs is it's text. And we live in a world of numbers. So the more that we can get the physics that you described in our space, and we get the right questions to ask to solve those problems, I think will be revolutionary in terms of what we can achieve. So I know we had a previous conversation, but I just think it's extraordinary.
Thank you so much.
Can you talk a little bit about the convergence of AI and regular human activity? A lot of talk about AI displacing humans, short-term or long-term. What is your vision on that?
Yes, so that's a great question.
Well,
and
thank you. AI, I just did it on ChatGPT.
Say it again.
I just did it on ChatGPT.
Okay. You can compare my answer with ChatGPT's answer.
Okay, go ahead.
Okay. So I have thought about this, and a lot of students also came to my office hour asking the exact same question, like, Professor, what should I study? That won't get me out of job, right? What should I study that still guaranteed that I'm relevant in 4 or 5 or 6 years? So my answer to them is that yes, AI will replace some of the jobs that I mentioned. 80% of workforce will be impacted. 10% of tasks will be impacted. There is a research that's saying what type of jobs are most likely to be impacted. And unfortunately, the white-collar jobs are most likely to be impacted. For example, I do a lot of white-collar jobs. I sit in front of the computer, I look at the data, I program, and all the things are most likely to be replaced. On the other hand, my husband is an experimental physicist, and he does a lot of handwork with fixing the machines, and he sometimes jokes that he's going to be the one who stays, because he won't be replaced, because robotics is still very far away with intricate hand-based movement. These won't be replaced, at least for the short time. But in general, I think we don't have to be super pessimistic about AI replacing jobs. Just like the example of our transition from carriages to cars, right? Before we had carriages and people were riding horses. And of course, like the carriages and the horses and whoever drives the carriages are no longer relevant when the cars come up. But then there are also new jobs that have been created. There are mechanics, there are body shops, people who work at body shops. And these kind of jobs did not exist before the cars. So you can make the similar analogy here that when we have AI that might replace some of the jobs, then we will have new jobs, such as those who will govern the operation of AI system and those who maintain the daily day-to-day operation of AI algorithm, and those who design laws, design policies, who coordinate different operations of component in AI systems. So these are the new jobs that will be created in the future. And then the new workforces will be, transitioned into this type of new jobs. I don't know whether that's better than ChatGPT or worse.
ChatGPT disagrees completely. But you're right. You're right. When I asked the question, it said, we still need plumbers in the future.
Yes. So that's something I try to learn on my side, just all this like house, home maintenance task, which I'm terrible at.
I have a question. I'd like to get your opinion on generative AI mimicking other people, whether they're fictional people, they don't exist, but they come across as real people and try to convince you to do something, or the case where they're an extension of an existing person, your parents or a friend or something, and they are talking to you and advising you and all of that. What is your thinking on how to govern that? And where does the legal framework tell us this is acceptable and this is not acceptable?
Yeah, that's a very hard question. I don't think I can give you an answer. One is I don't work on AI governance specifically or the implication of that, which is AI ethics. But I can give you some examples because there's always two sides to a coin, right? So when generative AI is imitating your mother trying to ask you for a large sum of money, right? Saying like, okay, I'm in terrible condition. I need, your financial support right now. That's basically like phishing, and that's illegal, right? That's bad. But then on other cases, I've heard stories where this children, they miss their past parents so much. They didn't get a lot of grandparents. Actually, they haven't had a lot of time spent with their grandparents, and they use generative AI to recreate their grandparents, and they have conversation with them, right? That's actually remnants of their childhood and all these nice memories, and that was such a beautiful story, like that's the good side of it, right? So then in terms of governance, I think we just have to come down to the human value of it, like what we believe is creating value for us as a whole, as a community, right? And some people out there will then form a committee and then write down the law about it. So that's my 2 cents. Sure.
Okay, so I have a question. In the comments, and you said the grandparents' memory. Actually, one of my undergrad students working on that project right now.
Okay, fantastic.
It's like a real, case, user case. And my question is, given you have a lot of success with AI, do you see anything that AI cannot do?
There's so many things that AI cannot do, right? So the example I mentioned about the embodiment to the physical world, like we're building the brain of AI right now, but the AI still cannot operate robotic arms to do very intricate tasks, let's say surgery, right? It's still very far away, even though there's some surgical robots, but they're not like learning to do surgery per se. And the other big element of AI is basically human emotion intelligence, right? Then I think a big part of us being human is we can understand each other. We can understand each other's, the emotion and being able to sympathize, right? And being to build this type of mutual understanding. But I think AI is still quite lag behind in this type of emotional intelligence. It's great at competing for math Olympia or coding Olympia, but if you ask AI to really become a therapist, right? I think I would say it's a long shot. And I think there's other technical challenges. For example, like how do we enable AI to work in situations where we have no data, right? So let's say we wanted to build a forecasting model in a new country that we have never collected a single data point before. How do we allow the AI to still operate in this wild field? And then how do we actually understand at the theoretical framework the underpinning mechanism of AI? Because right now, a lot of these models are sort of working as black boxes, and there's very little theory about why it works and what situation it fails, right? And that's kind of dangerous, because if we think about old-fashioned physics, at least we can characterize the failure mode of these models, and then we can have some guardrails around it when it goes exceeding this kind of regimes, the safety regimes. But then for AI models, despite a lot of advancement in AI safety, right, or AI governance, I don't think we have a very principled understanding of when and where it fails. Yeah.
Question over here.
Yes.
Probably your last comment is piggybacking a little bit off of this, but in this room obviously are supply chain professionals who do sourcing as a role, and I think you would agree that the products of the future will have embedded agents or AI embedded in the stack of the solution offering. As such, the role of supply chain in sourcing, selecting, qualifying, and compensating for AI agents, I assume would be part of our responsibility in the future. You made a comment now about the black box comment, but generally speaking, what advice and guidance and foresight would you have in how to do this kind of governance and sourcing for AI agents in the future?
Yeah, I don't know enough about sourcing to give a very insightful answer, but I'm actually very interested. I was talking to Helen about, because one of my students wanted to start a company around that for sourcing. and then, so I think like in terms of the interaction between like AI and like leaders in sourcing, I think you need to be prepared about how you would comprehend the decisions from the AI model, right? How much would you trust the decisions of the AI model? First, let's say if I have an AI model that can give you like confidence intervals, how can you comprehend this kind of confidence intervals? Let's say the model says, I'm going to recommend you to make this purchase with 60% confidence, versus the other one, I'm going to suggest you a much more profitable purchasing plan, but with 20% confidence. But which one are you going to trust? Then the other case is like, okay, in sourcing, obviously you're dealing with humans, right? On one side, everything is reasoning, logical. Then you basically figure out a financial plan to figure out what makes sense financially in terms of sourcing. But then on the other hand, you also have this human component who you wanted to work with as long-term partners. You may just don't like this like suppliers at all because how they work, their style, their personality, and these kind of things may be hard to be comprehended by AI, right? As I mentioned, AI doesn't really have emotional intelligence yet. So the governance here is really as human that you final evaluators, but you have a lot more information now beyond the data that you were provided. Now you have a set of recommendations provided by this AI engine, and you can always be the final one that makes the call, right? Do I trust the decision by the AI agent, or do I just say, no, I will go ahead with my personal insight? And of course, I think a more ambitious future is that we can sort of distill your decision process gradually into the system. There must be a pattern that you don't like about how AI make decisions, and can we learn from the pattern to make personalized AI agent for you, right, as a sourcing manager? I think that's a much more ambitious and interesting direction.
Thank you. Thank you for the presentation. Very insightful. Now, I speak only for myself.
Oh, thank you.
I don't understand a lot of the technical aspect of it. I think I'm more of a potential user of the technology for the organization. So my question is kind of with that lens in mind. If you look at building AI models, whether it's predicting demand, whether it's predicting supply chain risks, or looking at sourcing efficiencies in our businesses, what is the biggest challenge? Is it the availability of the causal data? Is it the modeling itself? Or is it organization change management? Meaning the tools are there, you can find all the data, you can build very good tools that give you more than 50% confidence level, but people as humans, we are slow to adapt the changes, right? So how should I think about potentially using different tools, and what's the biggest bottleneck or the challenges that will prevent us to take advantage of the new technology and make ourselves better?
I think that's a question actually for the audience. Like, I would really want to know, like, what is the biggest bottleneck for you as a user of the technology that prevents you from like using or kind of makes you feel hesitate to use this technology? I think that's a very excellent comment, like about data privacy. So there are some solutions about essentially obfuscating the data so that it's not backtrackable. There's also technologies about just deploying like a local version of the model, and then the model is never uploaded to the cloud. So then even like basically you have your own local version of language models, and then your data is not used as a training data for your competitors.
So there's a perspective that actually, especially the younger generation, talking about, clearly AI has its own word, right? Let's just say, give them the name AI word. And there's a word outside there, and you have more and more data going there. There's more and more agent going there. There's maybe our clone going there, who knows? So their younger generation is saying you have to be very nice to AI because they carry your reputation over there. So, now I say, good morning, ChatGPT, are you ready to work? Every morning, and then I say, yeah, I'm ready, bring it on. So, first of all, I wanted your opinion in terms of, should we be nice with AI, Secondly is also, since we talk about emotional intelligence, and I also teach it, but I have this interesting observation because people can get emotional, right? Although there's intelligence behind it as well. However, we're not that stable, we can get emotional. There's also a lot of mental stress going on. But every time you talk to ChatGPT AI, and it's stable 24/7, it's so nice to use, always like ready to go, right? So I do feel like they start acquiring some intelligence, emotionally. Therefore, sometimes I feel like more willing to deal with talking to ChatGPT versus talking to some people I don't like. What's your thought about it?
Yeah, I mean, I sort of agree. But the thing is, like, because about the first question, like, should we be nice to AI? I think it depends. Because, like, in AI, right, there is a separate research direction called adversarial text to AI, which means that we wanted to create the worst possible like responses or input for the AI, then it will become better. So if you are adversarial to an AI, you're helping AI to become better. Right? It's almost like if you want to train an athlete, you want to put them in the most harsh environment, give them the most strenuous test, and that will help them perform better in competitions. So, but in general, I think yes, we should be nice to AI because that brings the best of you, right? That makes you feel better as a person. But you can also be, you can sometimes be an asshole if you don't feel like it, right? So, then about the second question, yeah, because emotional intelligence is something very hard to quantify. There is IQ. There's also something called EQ, but I don't think any of the like survey-based data is accurate at all, right? Who is there to define what is emotional intelligence? And therefore, if you feel like ChatGPT has emotional intelligence, I won't argue with you, right? Because there's no such definition. And as long as you feel it's helping you in some productive, constructive ways, then I would say, good for you. Because that's what we set out to do as AI researchers. We want to build tools that make things easier for you. Okay? All right, thank you so much.
Besides tuning in, how else can we help support Oceanside Perspective, and how else can our audience give us more encouragement?
If you like our content, we love to produce more for you. But I would say maybe three things. You know, the first thing is really subscribe. If you're on YouTube, please subscribe. And if you're on LinkedIn, please follow us. We are very active on all the social media platforms. So please become our community. I think join us, that's the big thing. Secondly is, if you love us, I'm sure the people surrounded you would like us as well. So please share, please tell more people about what we do, the mission we're trying to achieve across generation again, so everybody is included. This is a very inclusive community. So please share and tell other people about Oceanside Perspective. The third thing, I think, come back to resources. I would really appreciate if you would consider that to donate to our cause for a great mission and for more content that we're going to create and benefit our community.
All right. Thank you so much for joining us today, Helen, and for talking to all of our Oceanside Perspective community.